Functions test review. Owners of a restaurant use a function B to analyze sales. B of n represents the rate of customers where n is the number of paying customers in a specified time interval. What would be the most appropriate domain for the function? So we're taking a look at the rate of customers in terms of people, and when we evaluate the domains as provided in choices 1, 2, 3, and 4, you have to take into account that you do not have a half a person, as in choice 3, and you don't have negative amount of people. So the obvious choice is 1. You can have 0 customers, 1 customer, 2 customers, 3 customers. For number 2, you're given the function of x is equal to 2x squared plus 4x minus 3. What is the value of f of 4? So 4 goes in for everywhere you see x. So 2 times 4 squared plus 4x, which is 4 times 4 minus 3. Do the math. And get 45. That's choice 3. The table below represents the function f. The equation that represents this function is. So all you have to do is substitute these values of x, in for each function and see if you get these outputs for y. So is 2 raised to the 2 power equal to 5? No, because 2 squared is 4, so this does not equal 5, so it can't be choice 1. 2 times 2 is also equal to 4, that's not equal to 5, so it can't be choice 2. Moving on to choice 3, we're going to do our substitution. 2 raised to the 2 power plus 1 is indeed equal to 5. 2 raised to the 3rd power plus 1 is 8 plus 1 is equal to 9. I'm going to try one more. 2 raised to the 5th power plus 1 is equal to 33. So this appears as though it works out. I'm going to check choice 4 just to rule it out and make sure that it doesn't work. So 2 times 2 plus 3, right there I can rule it out. 4 plus 3 is equal to 7, so that does not equal 5. So it's definitely choice 3. By the way, that's a test-taking strategy that you should be applying towards any test or quiz, as well as the Regents. So which relation represents a function? We know that with coordinates, what represents a function is when you have x values in the domain that do not repeat. So if we look at the domain for number 1, we have 0 and 0, so that's not a function. If we evaluate number 2, we have negative 7, that's repeating, have to rule out number 2. We have repeating values of 6 in choice 3, so that's not going to work. If we evaluate all the x values in choice 4, that does work. A daisy is 2 inches tall at week 0. So that's A0 is equal to 2 and grows 3 inches each week. So A1, 2 plus 3 is 5. A2, 5 plus 3 is 8. Week 3, 8 plus 3 is 11. So we need to check Roman numerals 1, 2, and 3, do our substitutions, and see if we get these outputs when we substitute our values of n. So starting with the 0 week, 3 times 0 plus 2, that works out. Moving on to the first week, 3 times 1 is 3 plus 2 gives me 5. That works. 3 times 2 is 6, plus 2 is 8, that works. And 3 times 3 is 9, plus 2 is 11. So it appears as though Roman numeral 1 works. So Roman numeral 2, 3 times 0 is 0, plus 2 times 0 minus 1 is a negative 2, so Roman numeral 2 does not work out. Now when you see something like this, f of n minus 1, that means use the value of the last term. So let's start off with week 1. Is 2 plus 3 equal to 5? Yes, it is. Is 5 plus 3 equal to 8? Yes, it is. Is 8 plus 3 equal to 11? Yes, it is. So Roman numeral 2 works as well. So choice 1 and 3 is choice 4. The diagrams below represent the first 3 terms of a sequence. So we've been seeing this question over and over again, and hopefully you're remembering what we need to do in order to solve this problem. So we're going to count up the shaded blocks. So this gives me 12 shaded blocks. This gives me 16. And this gives me 20. So my first term, n is equal to 1, I get an output of 12. My second term, n is equal to 2, I get an output of 16. And my third term, n is equal to 3, I get an output of 20. So all I have to do is substitute in and see which one of these equations for each of these choices will give me an output of 12, 16, and 20 when I substitute my value of n in as 1, 2, and 3. So looking at the first one, 4 times 1 plus 8 is 12, so we're good to go right there. Let's try the second term. 4 times 2 plus 8, 8 plus 8 is 16, so this works. And then 4 times 3 plus 8 is equal to 20. So it appears as though the first one, when substituting the terms in, will give us the same outputs as the shaded areas for the squares. But we need to rule out the other ones just to make sure. You never know if you make a mistake. So 4 times 1 plus 12 is equal to 16, so it's definitely not choice 2. 4 times 1 plus 2 is equal to 6 and not 12, so it's not choice 3. And 4 times 1 plus 4, 4 plus 4 is 8 and not equal to 12. So definitely it's choice 1. The table below corresponds to a function. Identify the function as linear, quadratic, exponential, or none of the above. So the first thing you want to do is take the difference of the y values and see if it's linear. If you get a constant difference for each set of the y values, then we can identify it as linear. If not, we have to move on to the second step. So 8 minus 4 is 4. 16 minus 8 is 8. 32 minus 16 is 16. 64 minus 32 is 32. Okay, so we get the picture. They're not the same constant, so we have to reject this as being linear. But since it's following the same pattern as the y values, this indeed is exponential. And if we had taken the differences of the original difference, the first set of differences here, and we got the same constant, then it would be quadratic. Hector gets better and better at a video game each time he plays. He scores 20 points in the first game, 25 in the second, 30 in the third, and so on. How many points will he have scored in all after his 15th game? So since Hector scores 20 points, 25 points, and 30 points, I see a common difference is equal to 5. I know that the value of the first term is equal to 20, and we want to know when n is equal to 15th what the value is. So I'm going to use an arithmetic sequence formula. an is equal to the value of the first term plus n minus 1 times the common difference. This formula, by the way, is given to you in the back of the Regents exam, so you just need to know how to use it. You don't have to have it memorized. So we know it's the value of n is 15 is equal to first term is 20 plus 15 minus 1 times d, common difference of 5. Do the math. Just plug that right into the calculator exactly the way you see it, and you'll get your value of the 15th game as 90. That's choice 2. Which graph represents a function? Because we have graphs, we use the vertical line test. This does not pass, this does not pass, this passes, this does not pass. So the obvious answer is choice 2. What are the next 3 terms of the sequence? 2, 4, 6, 8. So this is times 2 times 2 times 2. 16 times 2 is 32. 32 times 2 is 64. And 64 times 2 is 128. The function f has a domain of 2, 4, 6, and 8, and a range of 1, 3, and 5. Could f be represented by 2, 1, 2, 1, 6, 5, 8, 3? So it looks like they're pairing up the coordinate pairs like so. So 2, 1 works. However, a redundant 2, 1 does not work. You can't have repeating x values, and I see that going on here. So justify your answer. The function f cannot be represented by the coordinates or paired values because the 2 is repeated in the domain. Okay, so we need to substitute 2 everywhere we see an x. So 3 times 2 squared minus 8 times 2 plus 4. Put this in the calculator exactly the way you see it, or if you're going to do it by hand in hand, make sure that you follow PEMDAS, order of operation. So exponents comes first, so this is 3 times 4 minus 16 plus 4. 12 minus 16 is a negative 4 plus 4. So f, when x is 2, has a function value of 0. Given the following relation, state whether it is also a function and give a reason as to why. So I'm going to evaluate the x values only, and right here I see repeating values, so this cannot be a function. Paul has an iTunes gift card worth $55. After he buys his first app, the card's value is $52.75. After he rents the second movie, its value is $50.50. After he rents the third movie, the card is worth $48.25. Assuming the pattern continues, write an equation to define A of n, the amount of money on the gift card after n rentals. So Paul starts off with $55, and then it starts to decrease by a common difference of $2.25, and that's going to be times n, the number of apps or movies or items that he can buy on the iTunes card. So if Paul buys an app every Monday morning, how many weeks in a row can he afford to buy an app using his gift card only? Explain how you arrived at your answer. So the best case scenario is this. You got this equation, and the value, we're going to start off at 0, and that equation has to be greater than or equal to 0. I'm going to subtract 55 from both sides. I'm running out of room, so I need to continue up here. Now I need to divide this negative number here, so that means I'm going to change the direction of the inequality sign. So I have negative 55 divided by negative 2.25. Now I switch the direction of the inequality sign to greater than or equal to n. In which case I get 24.44. So 24.44 is greater than or equal to n, so n has to be a little less than that number, or else he's going to go over his $55 card. So we're going to round down to 24 movies or apps that Paul can purchase. So 24 rentals. That gets squeezed in here. Let's see if I can write it the other way. Okay, so let's just check it. 55 minus 2.25 times 24, and you're not going to have 0.44 rentals here. You can't have 0.44 of a rental, so you either round up or round down. In this case, we're going to have to round down, because if you round up, you're going to have too much, I bet. So that's what we're going to check. Okay, so plugging 24 in, we have $1 left on the card. If we plug in 25, you'll have a negative amount, so you won't have enough on the card. So 24 is the answer. If f of x is equal to 2x minus 3, and g of x is equal to 3 times 4 raised to the x power, find the value of f of 2 plus g of 3. So what I need to do is find the value of f of x when x is 2. So 4 minus 3 is 1. And I also need to do the same thing for g of x when it's 3. Okay, so make sure you complete 4 raised to the third power first, and then multiply 3 to that. That's 192. So now I need to add or find the sum of f of 2 plus g of 3. So the function values I have are 1 plus 192, which in effect give me 193. Eloise knits hats and then sells them on Amazon, an online marketplace. Let C of x equal to 2x plus 15 represent the cost C in dollars to produce 0 to 8 hats. So this is your domain. Create a table to show the relationship between the number of hats x and the cost C. So the cost C is your output for y. Let's substitute 0 through 8. And you can get this on the calculator also. 3, 4, continue over here. 5, 6, 7, and 8. So 2 times 0 plus 15 is 0 plus 15. Our output is 15. So my coordinates for 0 scarves, we have a cost of $15. So that's how much Eloise puts out in order to make these hats. So 2 times 1 plus 15. So 2 times 1 is 2 plus 15 is 17. So 117 is the next coordinate. 2 times 2 is 4 plus 15 is 19. So the cost is $19. 2 times 3 is 6 plus 15 is 21. And 2 times 4 is 8 plus 15 is 23. Keep going. 2 times 5 plus 15, 10 plus 15 is $25. 2 times 6 is 12 plus 15 is $27. 2 times 7 is 14 plus 15 is $29. And 2 times 8 is 16 plus 15 is $31. So the domain is 0, 1, 2, 3, 4, 5, 6, 7, and 8. And your range are your y values 15, 17, 19, 21, 23, 25, 27, 29, and 31. What is the meaning of C4? So what is the cost of 4 knitted hats, is what this means. Which is the same thing as asking, what is the value of y when the value of x is 4? So the value of x is 4 is right here. That means the cost is 23. And that's $23. So that concludes the notes for this review on functions. Your test is tomorrow. Please study. Please rewatch this video. If you have any questions, don't hesitate to ask. I will help you through it.